Did you know that every 7 years your body has essentially replaced itself? Yes, you heard it right. This fascinating fact stems from the continuous process of cell regeneration within our bodies. But what does this really mean? Let's explore. Our bodies are composed of trillions of cells, each with their own lifespan and function. They're like tiny workers, tirelessly performing tasks to ensure our bodies operate smoothly. When these cells become old or damaged, they are replaced with new ones through a process called cell regeneration. This process is happening constantly, right inside you, even as we speak. Now, you might be thinking that all cells are replaced at the same speed, but that's not the case. Different cells have different lifespans. For example, the cells in our stomach lining are replaced every 5 days. Yes, every 5 days. This rapid regeneration is necessary because the stomach lining is constantly exposed to harsh digestive acids and has a tough job to do. On the other end of the spectrum, our skeletal system, the sturdy framework of our body, takes a whole 10 years to completely regenerate. It's a slow process, but it's crucial for maintaining the strength and integrity of our bones. Why does this matter, you ask? Well, the rate and efficiency of cell regeneration have a significant impact on our health and aging. Efficient cell regeneration helps keep us youthful and healthy, while a slowdown can lead to early aging and various diseases. But it's not all doom and gloom. We can influence our cell regeneration through lifestyle choices. A balanced diet, regular exercise, and good sleep can all promote healthy cell regeneration. So the next time you look in the mirror, remember this. You're not just looking at the you from yesterday or even a year ago. You're looking at a body that's constantly changing, renewing, and regenerating. So in essence, the you from 7 years ago is not the same you sitting here today. Amazing, isn't it? The human body truly is a wonder of nature, ever-changing and ever-evolving. Keep that in mind as we journey through the rest of this fascinating exploration of the human body. Ever felt like your brain is running out of space? Well, it's far from it. Imagine your brain as an ultra-advanced storage device with an estimated capacity of around 2.5 petabytes. That's equivalent to a staggering 1 million gigabytes. For perspective, think about how many songs, photos, or videos you can store on a single gigabyte. Now multiply that by 1 million. That's the immense storage capacity of your brain. But how does this compare to the digital world we live in? To put it in context, it's estimated that the entire digital universe, which includes all the data created, replicated, and consumed in a single year, is expected to reach 44 zettabytes by the end of 2020. 1 zettabyte is equivalent to 1 billion terabytes, or 1 trillion gigabytes. So, yes, in comparison, our brain storage capacity seems a tad smaller. However, consider this. The entire written works of mankind from the dawn of recorded history in all languages is estimated to be around 50 petabytes. That's just 20 times the storage capacity of a single human brain. Now let's bring it back home. Think about the largest companies in the world, the ones that handle an unfathomable amount of data every day. Google, for instance, processes over 20 petabytes of data per day. That's 8 times the storage capacity of your brain, processed in just 24 hours. But remember, unlike data servers that store information passively, your brain not only stores but also processes and interprets this data, making connections and sparking ideas. It's a dynamic, living, breathing hard drive capable of feats no artificial device can replicate. So next time you forget where you left your keys, it's not because your brain is full. It's simply that, amidst the vast universe of information it's handling, your keys might not have been the top priority. We can't blame it, can we? Think your 4K TV is impressive? Your eyes might beg to differ. The human eye is an extraordinary piece of biological machinery. It's estimated that if the human eye were a digital camera, it would have a resolution of approximately 576 megapixels. That's more than 100 times more detail than a top-of-the-line 4K television. But unlike a digital camera or a TV, the human eye doesn't perceive the world in pixels. Pixels are the tiny squares of color that make up a digital image. But when you look around, you don't see a mosaic of tiny squares. Instead, you see a continuous, smooth panorama of color and light. That's because your brain is remarkably good at stitching together the raw visual data it receives from your eyes. So how does the eye achieve this astonishing resolution? It's all down to the densely packed light-sensing cells in the retina. the thin layer of tissue at the back of the eye. There are two types of these cells: rods, which are sensitive to light and dark, and cones, which detect color. Together, they create the rich, detailed images we perceive. But there's a catch. Not all of your retina is a high-resolution sensor. The very center of your field of view, a region called the fovea, has the highest concentration of cones and thus the highest resolution. But as you move away from the center, the resolution drops off dramatically. That's why things in your peripheral vision are less detailed. This is where your brain steps in. It's constantly moving your eyes around, scanning the world around you, and stitching together these high-resolution snapshots into a coherent, continuous picture. It's a bit like a jigsaw puzzle, with your brain expertly fitting all the pieces together. So while your 4K TV might boast an impressive number of pixels, it's still no match for the complex, dynamic system of your eyes and brain working together. So while technology is catching up, your eyes are still the best camera you own. Have you ever wondered how fast a sneeze can travel? It's not something you typically ponder, but when you do, it's quite fascinating. A sneeze isn't just an everyday occurrence. It's a high-speed launch of tiny particles racing out of your body like race cars on a speedway. A sneeze is essentially a powerful expulsion of air from the lungs through the nose and mouth. It's your body's way of getting rid of irritants that have made their way into your nasal passages. But just how fast does this expulsion occur? Well, hold on tight, because a sneeze can travel at a speed of up to 100 miles per hour. Yes, you heard it right, 100 miles per hour. That's faster than a cheetah can run, which is the fastest land animal. Now, you might be thinking, so what? Why does the speed of a sneeze matter? Well, it's not just about the speed, it's about what's in the sneeze. Sneezes are filled with tiny droplets of fluid, each containing thousands, if not millions, of germs. At 100 miles an hour, these germs can be launched up to 27 feet away. That's almost the length of a London bus. This high-speed germ launch has significant implications for disease spread. When someone sneezes without covering their mouth, those tiny germ-filled droplets can land on surfaces or be inhaled by people nearby, potentially spreading illness. This is why it's so important to cover your mouth when you sneeze, either with a tissue or the crook of your elbow. By doing this, you can help to prevent the spread of diseases like the common cold or the flu, keeping those around you healthier. So the next time you feel a sneeze coming on, remember this: you're not just sneezing. You're launching germs at race car speeds. So remember, next time you sneeze, you're launching germs at race car speeds. Your hair is stronger than you think. Now, that's a statement that might raise a few eyebrows, but let's dive into this fascinating fact, shall we? Imagine a single strand of hair, seemingly delicate, almost weightless, as it falls across your forehead. It's easy to underestimate its strength, isn't it? But don't let its slender appearance fool you. A single strand of human hair, as thin and delicate as it may seem, can actually support up to 100 grams in weight. That's approximately the weight of a small apple, all resting on a single strand of hair. And that's just one strand we're talking about. Let's take this a step further. An average human head is adorned with about 100,000 to 150,000 hairs. Now, if we multiply the weight a single strand can support by the total number of hairs on a human head, the numbers become truly staggering. Here's an amusing thought. If we were to combine the strength of every hair on your head, theoretically, your hair could support the weight of 2 average-sized elephants. That's right, 2 full-grown, massive elephants hanging from your hair. It might sound like something straight out of a cartoon show, but it's a fact rooted in the fascinating biology of the human body. Now, of course, we're not suggesting that you try this at home. Hanging elephants or even apples from your hair is not recommended. After all, despite the impressive strength of individual hair strands, our scalps are not designed to bear such extensive loads. But isn't it an intriguing idea? The very hairs on our heads, which we often dismiss as weak or insignificant, are capable of such extraordinary strength. It's another example of the amazing resilience and capabilities that lie within the human body, often hidden in the most unexpected places. So, while we don't recommend trying to lift elephants with your hair, it's an impressive testament to the strength of human hair.